So, you want to install Moodle 5.2 on Ubuntu 24.04 without following some outdated tutorial and just hoping for the best? Good news, that's exactly what we are doing today. We will start from a completely clean Ubuntu machine, install everything Moodle needs, prepare the database, run the installer, and by the end of this video, you will be looking at a working Moodle login page. I will explain what each command does at a high level, enough so you actually understand what you are typing without turning this into a full Linux course. And don't worry about pausing every few seconds to copy commands. The full command file is in the description. One quick note, before we dive in, I am doing all of this in a local virtual machine, so we can practice safely. The steps are almost identical on a real server, but production topics, things like domain name, SSL, firewall rules, backups, cron, and hardening deserve their own videos, so I will cover those separately. Hi, welcome to Open Education Operations. Let's get Moodle running. Before we start typing commands, let's take a quick look at what we are working with. This is Moodle's official requirements page. For this tutorial, I am going slightly more comfortable than the minimum. I am using a VMware virtual machine running Ubuntu 24.04 LTS with 4 GB of RAM, 2 virtual CPUs, and a 20 GB disk. For a local test install, that's plenty. If you are planning a production server later, my advice is don't go too low. Moodle can run on modest resources, yes, but it's a lot happier when it has room to breathe, especially once you have real users, file uploads, backups, and plugins in the mix. The only other thing you need is a user with sudo access, because we will be installing packages and changing system configuration. Alright, we know what we are working with. Let's begin. Before installing anything, I always like to verify the environment first. It only takes a minute, and trust me, it saves you a lot of confusion later. First, let's confirm the Ubuntu version using this command. Like we expect, Ubuntu 24.04. Next, let's see for the kernel information. There is nothing to act on here, but it's good to have it documented. Future you will be grateful if you ever need to open a support ticket or file a bug report. Now, let's check whether PHP, Apache, or MySQL are already sitting on this system. On a clean VM, all three should come back with something like command not found. And believe it or not, that's good news. It means we are starting from a truly clean system. No old packages, no leftover configurations waiting to trip us up. Now let's check disk space and memory. df-h shows disk space in a human-readable format, and free-h does the same for memory and swap. Finally, let's look at the network interfaces. This shows the IP address of the VM. If you plan to open Moodle from your host's computer, write this IP down, you will need it. If you are opening the browser inside the VM, like I am, localhost is all you need. For this recording, I will keep things simple and stick with localhost. We know exactly what machine we are working with, and it's clean. Now, instead of guessing what's installed, we can start building on solid ground. The first step on any Ubuntu server is always the same. Update the package list and upgrade what's already there. This way, we are pulling from the latest repositories and no outdated package can cause a conflict down the road. Let's use this command. This one line actually does two things. apt update refreshes the list of available packages, and apt upgrade installs the updates for whatever is already on the system. The dash flag is just to say yes for us automatically, so we don't have to sit there confirming each package. Once this command is done, we need now to install a set of base utilities that Moodle and its stack will rely on. I will keep the explanation of this one high level. Together, these tools let us download Moodle, manage PHP dependencies, process files, and support some optional Moodle features, things like spell checking, diagrams, PDF processing, and antivirus scanning. The two stars of the show for our purposes are get, which we will use to download Moodle from the official repository, and Composer, which Moodle uses to install its PHP dependencies. You will notice UFW in there too. That's Ubuntu Uncomplicated Firewall. We are installing it now, but we won't configure any firewall rules in this video. That's belong in the production setup video. Nothing too exciting yet, I know, but we now have a clean, solid base. And with the base tools in place, we can move on to the heart of the Moodle stack, PHP. Moodle is a PHP application, so everything from here on depends on getting PHP installed and configured properly. Let's install PHP along with the extensions Moodle needs. Moodle 5.2 requires PHP 8.3. And here is a nice bit of luck. Ubuntu 24.04 ships PHP 8.3 right in its standard packages. No extra repositories, no workarounds. We will be using this command. I know this looks long, but the idea behind it is simple. The first part installs the PHP runtime, the command line PHP tool, and the Apache module that lets Apache process PHP files. Everything after that is PHP extensions Moodle needs for database access, images, language support, zip files, XML, web requests, authentications, and performance. I am not going to walk through every extension one by one, because honestly that will turn this video into a PHP extension museum. Here is the only thing you really need to know. If a required extension is missing, Moodle will stop during installation and tell you exactly which one. By installing them all now, we skip that whole back and forth. Now let's verify that PHP is working and check which version we got. Alright, this should show PHP 8.3. Then let's make sure that the important extensions are actually loaded. php-m lists every loaded PHP extension, and the egrep part filters the output down to just the ones we care about right now. If you see them all listed, great, we are in a good shape. PHP is now installed, but before we move on, there are a few default settings that will cause us trouble later if we don't fix them now. Moodle needs a PHP setting called max input vars to be at least 5000, but the default value is only 1000. If you leave it unchanged, some Moodle settings page will silently fail to save your changes. No error messages, no warning. Things just don't work. It's the kind of bug that makes you question your sanity at 11 p.m. So let's fix it right now before it ever becomes a problem. First, a quick check to see which php.ini files are actually in use. This matters because PHP keeps separate configurations files, one for the command line and one for Apache. We need to update both. Now let's apply the fix, along with a few other recommended limits using one command that handles both files at once. I know this looks a little intense, but what it's doing is actually very practical. The first line detects PHP version automatically, so we don't hard-code it. Then the loop edits both PHP configuration files, CLI files, and Apache file. It sets max input vars to 5000, which matters because Moodle has some genuinely massive forms, especially in the admin pages. It also raises the upload size, the post size, and the memory limit to 256 megabytes, giving Moodle more room to handle file uploads and larger requests. Now you might be wondering, shouldn't we restart Apache for these settings to take effect? Great question, and here's a little detail worth understanding. Apache reads php.ini once when it starts. If Apache were already running, yes, we would need to restart. But here is the thing, Apache isn't even installed yet. So when we install it in a few minutes, it will start for the very first time. On that first start, it reads the php.ini file fresh, with our new values already sitting there, waiting for it. No restart needed because there is nothing running to restart. It's one of those things that's obvious once you see it, but genuinely confusing the first time. Let's verify that the CLI config was updated correctly. If you see 5000 and 256 in the output, the PHP tuning is done. Now PHP is installed and tuned, but an application without a database is just a pretty shell. So let's give Moodle somewhere to store its data. Moodle needs somewhere to keep everything: users, courses, grades, quiz attempts, settings, plugin data. All of it lives in the database. For this, we are using MariaDB. It's a fully open source drop-in replacement for MySQL, and it's Moodle's recommended database engine, so it's an easy choice. This command installs the MariaDB server plus the client tools we will use to talk to it. Next, we need to enable and start the service. Two things happening here. Enable makes MariaDB start automatically whenever the machine boots, and -- now starts it immediately, so we don't have to wait for a reboot. Then comes a step you should never skip: the MariaDB secure installation script. This is what takes the database from fresh install to actually safe to use. Using this command, the script walks you through a few security questions. For a clean setup, my recommendation is simple: say yes to removing anonymous users, to disabling remote root login, to removing the test database, and yes to reloading the privileged tables. If the prompt looks slightly different on your system, don't panic. The exact wording changes between versions, but the goal stays the same: strip out the insecure default and keep the database server clean. MariaDB is up and secured, but right now it's an empty house, so let's create a dedicated space in it for Moodle. Now let's create a dedicated database and a dedicated user just for Moodle. And here is an important principle, one worth remembering well beyond this tutorial. We never let an application use the root database account. Root can touch everything. If Moodle ever had a SQL injection vulnerability and no software is immune, you would want its database user logged to the Moodle database and nothing else. This is the SQL query we will be running. One important thing before you run this: replace strongdb password with your own strong password. Please don't ship the placeholder. So what does this actually do? It creates a database called Moodle using UTF-8MB4, which means full Unicode support, including accents, non-Latin alphabets, and yes, even emojis in forum posts. It also creates a user called Moodle user, who can only connect from localhost, and it grants that user exactly the permission Moodle needs on the Moodle database. No more, no less. That's the principle of least privilege in action, and it's a much better habit than handling the root account to every application. Let's now use this command to use the MariaDB console and pass our SQL query. Our query is executed. We can use exit followed by semicolon to return to the terminal. And with that, the database is ready and waiting. The data layer is done. Now Moodle needs a front door. Time to set up the web server. We will be using Apache as the web server. Apache is the piece that sits between your browser and Moodle. It receives the HTTP requests and hands them over to PHP for processing. Let's install it using this command. Then, just like we did with MariaDB, we enable and start it. Next step, we need to create what's called a virtual host configuration. A virtual host tells Apache when a request comes in on port 80, serves the files from this specific directory. This creates a configuration file called moodle.conf. And if you only remember one line from it, makes it this one. Starting with recent Moodle versions, the web server should serve Moodle's public directory, not the entire code directory. That's a deliberate security improvement from the Moodle team, and that's exactly why our document root points to the public folder. One more detail: server name localhosts works if you are opening the browser from inside the VM, like I am. If you want to reach Moodle from your host machine instead, replace localhost with your VM's IP address. Now let's activate our configuration. 3 quick commands. I2 this site switches off the default Apache welcome page. A2 insight switches on our Moodle configuration, and reload applies the change without fully restarting Apache. Now take a second to appreciate where we are. PHP, MariaDB, and Apache, the full stack is alive. The stage is built. Now let's bring in the start of the show, Moodle. This is the part that actually puts Moodle on the server. We are using Git instead of downloading a zip file, and I want to take 30 seconds to explain why, because I think it's genuinely worth it. Moodle does provide official zip packages, and those are perfectly valid. But with Git, we get precision. We can pin the installation to a specific release tag, in our case version 5.2.1, so we know exactly which version of the code is on the server. Git also makes future maintenance much cleaner. Instead of downloading a new zip and manually swapping out files, and praying you didn't miss one, you fetch the latest release and switch version with a couple of Git commands. You still need backups, plugin checks, and the proper Moodle upgrade process, of course, but the code management part becomes clean and traceable. It's the more professional approach, and honestly, once you know the basic commands, it's no harder than juggling zip files. Let's start by setting two environment variables so we don't have to keep typing the same paths over and over. Moodle code is where the Moodle application code will live, and Moodle data is where Moodle will store uploaded files, cache, sessions, and other runtime data. Keep those two ideas separate in your head. It will matter in a few minutes. Quick sanity check on the variables. Good. Now let's create the directory and clone Moodle from the official GitHub repository. Fair warning, this takes a few minutes. Moodle repository is large, so the exact time depends on your machine and on your internet speed. Perfect excuse to grab a coffee if you want. On my end, I will speed this up in the edit and meet you on the other side. Done. The Moodle source code is now sitting in the Moodle directory. Let's do a quick sanity check and make sure the public directory exists and contains index.php. There it is. If index.php is in place, Apache has its main Moodle entry point to serve. Now let's move into the Moodle directory. One small bump to smooth out. Because we cloned the repository using sudo, Git might complain about the directory ownership. This command tells Git that the directory is safe. With that out of the way, let's fetch the release tags. Then we list the stable Moodle 5.2 tags, filtering out the alpha, beta, and release candidate versions. We want stable releases only. For this tutorial, I am checking out the 5.2.1 tag. Just keep in mind, for a production site, you would want to stay current and use the latest stable patch in the 5.2 series once it's available. So, Moodle's source code is in place, but it's not quite complete. The application still depends on several PHP libraries, and rather than hunting down those manually, we will let Composer do the heavy lifting. Before running any commands, make sure you are still inside the Moodle directory. Composer needs to be run from there. Why? Because Composer reads Moodle dependency files, figure out which PHP libraries are required, and install them into a directory called vendor. It's like a shopping list that fills itself. So let's run it. Breaking that down, Composer install reads the dependency configuration and installs the required libraries. --no dev skips the development only dependencies we don't need on a server. And --class map authoritative builds an optimized class map which gave us a small performance boost for free. Now that Composer has done its job, we need to set the final ownership and permissions on the code. Here is the thinking behind this. Root becomes the owner of Moodle code, which means the web server can read the files, but it can't modify them. Directories get 755, so they can be opened and read, and files get 644, so they can be read but never executed. In other words, the web server gets to look but not touch. That's exactly the relationship we want. Last check, let's confirm the vendor directory exists. It's there, which means Composer installed everything successfully. The Moodle code is officially ready. But the code is only half the story. Moodle needs a private storage area, a place for uploaded files, user data, sessions, and cache. And here is the key design decision. That directory lives outside the web root. Why does that matter? Because outside the web root means a browser can never directly request a file from that directory. Even if someone knows the exact path, files uploaded by your students or staff are never reachable through a URL. That's not a nice to have, that's user privacy by design. Let's create the Moodle data private directory now and give it the right permissions. Step by step, the first command creates the directory. The second hands ownership to www.data, which is the Apache user on Ubuntu. Then we lock it down with strict permissions, 700 for directories, 600 for files. The result, Moodle data is private and writable only by the web server user, which is exactly what Moodle needs, not in more, not in less. Notice the contrast, by the way. The code directory is readable but locked, while the data directory is private but writable. Two different jobs, two different sets of permissions. Moodle data is ready. There is just one small adjustment left before we can run the installer finally. Remember how we locked down the Moodle code directory after Composer? There is one temporary exception we need to make. During installation, Moodle needs to create a single file, config.php, right in the main Moodle directory. And since we just made that directory read only for the web server, we need to crack the door open just a little. This allows the web server to write to the main Moodle directory and only the main directory. And to be clear, this is temporary. It's only for the installation step. And once we are done, I will show you how to lock it right back down. And just like that, every piece is in place. PHP, MariaDB, Apache, the Moodle code, and the permissions. This is the moment where a pile of carefully configured software actually becomes a Moodle site. Let's run the installer. First, we set the domain variable. For my local VM, localhost is the right choice, since I am browsing from the inside the VM. If you are opening Moodle from your host machine instead, use your VM's IP address here, and make sure it matches what you put in the Apache configuration earlier. Those two values need to agree. Now the main event. We need to run the installer as Apache user. Two things to replace before you hit enter. StrongDB password is the database password you created earlier, and the admin pass is a new strong password for the Moodle administrator account. Yes, the command is long, but that's actually the point. Instead of clicking through installer screens, we are answering every question upfront right in the terminal. At a high level, we are telling Moodle, here is your site URL, here is where Moodle data lives, how to connect to the database, what to call the site, and here is the admin account to create. And notice that we run it as www.data, the same user Apache uses to run Moodle. That keeps the installation as close as possible to the real web server context, which avoids a whole category of permission surprises later. If everything goes well, Moodle creates config.php, builds the database tables, and finishes the installation. As most of the time, that's the end of the story. But let's be honest, tutorials are most useful at the exact moment something goes wrong. Usually at 1 AM, usually with too much coffee. So, before we celebrate, let me show you a recovery path. During my own testing, I ran into a situation where the install only partially completed. The config.php file was created, but the database installation needed to be finished separately. If this happens to you, don't panic, and definitely don't start over. Moodle has a dedicated database installer for exactly this case. To be clear, this command is only for the recovery case, when config.php already exists, but the database setup did not finish. If your main installer completed successfully, skip this entirely. Now, whether you needed the recovery command or not, please don't skip what comes next. The installer is done, which means that the temporary write access we opened earlier has served its purpose. Time to close that door again. The moment the installation completes, the very next thing you do is lock the permissions back down. This part is not optional. That temporary write access existed for only one reason, to create the config.php file. That's done now, so let's remove it. You may be asking why this matters. Config.php contains your database password in plain text. If you leave the Moodle directory writable by the Apache user, then a file uploaded vulnerability in any plugin, and there are thousands of Moodle plugins out there, could potentially let an attacker overwrite your configuration. By handing ownership back to root, you close that attack vector completely. It's a small step, maybe 30 seconds of work, but it's the difference between a good habit and a future incident report. And now the satisfying part. We have been staring at a terminal for over 20 minutes. Let's find out if all of this actually gives us a Moodle site. Since my domain variable is localhost, I am opening the browser inside the VM. And the moment of truth, and there it is, Moodle 5.2 running on Ubuntu 24.04. Think about everything that's behind this one login page. The server packages, a tuned PHP, a dedicated database, a configured Apache, the Moodle code pinned to an exact version, a private Moodle directory, and permissions locked down properly after installation. Now, is it production ready? No, and I want to be completely honest about that. But it's a very strong foundation, and the production pieces deserve their own videos. In future videos, we will build on this foundation: cron, email configuration, a real domain name, HTTPS, backups, and full production hardening. If this video helped you, subscribe to Open Education Operations. There is a lot more coming on Moodle, OpenEduOps, Canvas, and other open source learning platforms in general. Thanks for watching, and I will see you in the next one.